Hi, welcome to this new video. I'm Sergio, I'm a computer vision consultant, developer, and course instructor, and I build computer vision solutions to help companies improve their process efficiency, reliability, and scalability. Today we're going to see a people flow tracker. I built this solution like a prototype to track the flow of people on big areas. This could be airports, it could be shopping centers, or like big spaces also outside in the city, and so on. We will see in this specific video, if you're a developer, how to build such solution from scratch. So what are the steps to build such solutions? And also what are the critical points when we build tracking software in not control light environment, like for example this one that you saw at the beginning. And also, if you have a company, you will understand when it's good to implement such solutions, what are the limitations also, like from the camera that you already have, if there are certain limitations when integrating object tracking, and so when it's good to invest and when it's not possible to do this. We'll see everything right now. Let's go. Let's start talking about the software side, like what are the cores of such program. I will identify like 3 cores to build this specific program. The first one is object detection, the second one is object tracking, and the third one is object counting. Of course, it's more complex than this because after the counting we can have the trajectory, we need to understand the flow, and all of these must be packed into a software that can be used on different cameras, different computers, different hardware. Like there is some complexity behind that, but the core is object detection, tracking, and counting. First one, let's see this object detection. Object detection means associating a bounding box per each object detected. I'm talking about object because object detection is in general. We can identify, count, track anything, but today we are talking specific about people. So in this case will be put a bounding box identifying each person, we have object detection. This is pretty simple. You might be already familiar with this because we see a lot of this stuff on the internet where there are videos and there are like new algorithm coming every month for object detection, and this is pretty common knowledge, at least right now in 2023. What gets more challenging is the second step, and it's object tracking. Nowadays, still, this is a challenge because detecting a person and tracking the same person is quite a different task, and we will understand now why. After object detection, let's move. What is object tracking? Object tracking is the part of the software that will allow us to track people, or to say it in simple words, associating a univocal ID for each single object. Let's take, for example, this ID right here. You see ID 18, so there is a bounding box for a person with the univocal ID associated, which is 18. Let's say, for example, this one somewhere in the middle, which has ID 3. When we use object detection on a video or in real time, a video is nothing more than a frame after frame. So when you see also, like for the cameras, it's written also FPS, which is frame per second, where like standard we have 30 frames per second, faster cameras 60 frames per second, and more, and so on. So it's frame after frame. Like for the computer, it's just picture after picture, and there is no connection, like no tracking history of what was that person, like that object before. That's why with object tracking, we need to follow like the object during time. So from the previous frame to the next frame until the object exists in that specific video. And so when we associate the univocal ID to the object, you see in this example now, I'm taking like the 3 as example. When we go to the next frames and that person is moving, to have a good tracking, we need to still follow that person with the same ID. If a new ID is associated, it gets lost, it means that the tracking is not working well. And so in this case, now of course, this is a video sample that I'm using for this prototype. I'm freezing now frame by frame so that you can follow along. And we can check that now that ID3 is always ID3 even after like we move on. This one is still always ID8, this is ID11, and so on. There are different algorithms for object tracking, and this is getting of course, this is improving over time. Like each few months we get newer, better algorithms, but the concept usually of these algorithms is to associate an ID to the object. Let's now talk again of this ID3. The algorithm will follow this object for a few frames, so it will just predict where this object is going to the next position. It will also understand how fast this object is going. So if someone, let's say, if the person 3 is here, let's say that the person 2, it's not the case, but let's say that the person 2 is running very fast. After a few frames, the algorithm can predict what will be the next position and where we are going to find that specific object. This is one of the things that the sort algorithm for object tracking does, because it makes an estimation of the next position. We have deep sort, which is slightly more advanced. We have OC sort, we have byte track, we have strong sort. We have so many algorithms if you check them, and each of them has pros and cons. We'll not get into these specific things. In general, when we have like a big space and a good camera positioning, even a basic algorithm can do some good tracking and very high reliable prediction of that. So object detection first, object tracking is the second step. What is after object tracking? We have object flow or object counting. Let's see that. As you see in this image, I have some region defined. You can see like red lines, and this is what I use for object counting. First, we define a region of interest, and it's a specific area where when people are crossing, so in this area we put a line where people are crossing that specific line, then we add the count. Let's say an example. So this is the area that I have. We will only detect people that are inside this area. Why do we need a region of interest? That's very simple, because when we take a very big region and we have like such huge area, there are parts where we of course cannot do the tracking. So all the part that is outside of this region very far, there are hundreds of people which are so small that we can't identify. So the object detection algorithm, the object tracking algorithm will just give us not good information, because we get a bounding box, and also the IDs will be pretty much random. Of course, they will give you an idea of how many people are there, but they will not be reliable. So unless you have a camera placed on top and you have a very small region, which is rare the case from CCTV camera, it's always necessary to select a region of interest for the area where we want to do the tracking. So what I will do now, we have a defined region of interest, this in the red. I'm showing you the bounding box for everything in the screen. What is out of this region will not be detected. So I'm going to deactivate from the code all the detection of everything that is outside of this region. So this one must be removed from the detection. I will do that, and we will focus more specifically now on the counting. Right now, as you can see from this footage, we have just one person inside the region of interest. So one person inside this defined area right here. We are only detecting and tracking that specific person. To this specific person, the ID 255 was associated. And of course, if the tracking is working well, this ID should stay with the person. How long should this stay with the person? As long as the person is inside the region of interest. And what we will do, you can see that I have a full region, but I have also another like line where the person is crossing. Like this line is just a center of a region where I'm counting like the specific person. So once the person enters inside this, we can say ID 255 is inside, so we're going to save, like, we can save this either on an array if we're working with this in real time on a database. We can say ID person 255 cross the line. And we have like counting one, ID 255. Then we have 302. 302 didn't cross yet, so we have 302, 53. So what is now the tracking? We added 3 ID because we check on every frame, is ID 302 inside the region of interest, like the specific counting area? If yes, add these 2 people that cross the line. So we will say 255, 53, 302, they cross the line. How many people cross the line today in this specific area? 3 people, because we have like the ID for each of them. So once we get the tracking, like correct tracking, then of course like the counting is a very simple programming operation. You just need to add the ID to all the IDs that cross the specific area. How about the flow? Because this is not only counting, but it's also about flow. What we are doing to track the flow, it's still a simple operation, because let's take into account the ID 302, or maybe let's focus on some other ID. So I will find some other that is crossing the area, so we will focus step by step and try to understand what is the flow of that. So the person is just crossing the area. What can we do? We can store and track these over time. So in the moment when we see this an ID, so we have object detection of the bounding box. The ID is associated, we save this ID, and also we save the position. We can save like the bounding box, we can save the center point. This is the first time we see ID 843. Let's say that we save the center point. This ID is of course crossing frame after frame, let's say a few frames. So each frame we have like some new point like this. So let's go this way. So all the points will be like this. Of course, these are over time. So this is the first point and this is the last point. So 1, 2, 3, 4, 5, 6, 7, 8. So this is the 8th point. Okay, this doesn't look like 8, but it's an 8. This is the 8th point that we have for this. How can we understand the flow? Of course, this is basic geometry now, because if the first point is right here and the last is right here, we know that the direction is that one. So very simply, if the y-axis, in this case, if the last y-axis of the ID 833 is bigger than the first one, then the flow is up. If it's the opposite, then it's down. Very, very simple. We have like the movement of the person over time, and with that we can understand it's going up, the person is going down, it's going left, right, it's going like northwest, also like different. Like if you have a lot of directions, we can also calculate that, and we can also estimate if the person is going always straight. We can also estimate like where the person is going. Based on this, like if we want to make a prediction. So there are many things that we can do when we check the flow. With this information that I'm showing you right now, so storing this over time, we can also show like an arrow of where the person is going. So let me now activate this function from the script, and let's see what information we can display once we have the history and trajectory of the person. As you can see right here, we can display an arrow. So they are overlapping now with the number, but you could see there is a blue arrow. So blue arrow, it means up, and also change the color to make it more understandable. When it's green, it's down. And I'm saving and displaying few points. So you see the line that I'm tracking, I'm drawing behind the object is like the flow, the trajectory of where the person was, plus the arrow with the basic geometric concept that I explained. Going further with this footage, we will see now ID 334, we have arrow down and we have like the last few points of where this person was going. So you see all the trajectory. 334 is going down, and so we have this down, arrow down, and this up, arrow up, and we can easily understand their trajectory. This, of course, can be structured in a way that you can save this on a database. You can save like the moment, so you can say like also a timestamp on the database of each specific ID. You can also have bigger elaboration of the trajectory if there is some improvement to make, for example, on the flow right there, and so on. So there is a short line, but this can be longer. After we have such information, we can save them on a database, and we can elaborate the information and display that on the screen. Let me show you a very basic graphic that we did for this to show like this demo on the screen, and we will talk about that. This is a basic graphic that we built with also like basic information like total people of the day today. So we have like the people going up this value, going down this value. Then we have a graph. This graph is also generated by the software, which can show, like in this case, like current month. It can show like day. Of course, this is very custom graph that depends on the need, can be done. And of course, this is maybe it's not even like the best graphing also distribution to put such information, but this was just a demo to display what we can show with such software. And then of course we have like the average people like per hour, from midnight to 8 in the morning, from 8 to 12, from 12 to midnight again. And this information of course will be updated in real time when the software is running in real time. I'm running this on a video footage, but of course the same software like this, instead of running this on a video, I will run this from a camera. It will just work in real time without any problem. Let's quickly see how this performs. It's very simple. We have a person which is going up, this person right here. When this person crosses this line, we should see this value 1412 to increase to 1413. If that doesn't happen, it means the software is not working. So the person is crossing, we see the area, so the line when it's counting lights up, and we have 1413, and of course it increases also this one, and over time you will see also this happening in the graph. Let's see some other person. So now it should go to 1414. It does. This increases also to a higher number, and so on. Let's now discuss briefly about the hardware that you need for to run such software. Nowadays, with the improvement of the algorithms, also not only the hardware is improving, but the algorithms are improving, so we need even less powerful hardware. This means that with a laptop, we can easily run this in real time. With smaller devices like the NVIDIA Jetson, Nano, Xavier, we can run this. Of course, for such smaller devices, they have like limitations, so it's also like they need to be somehow improved, like to get a good performance. But with laptops or like computer with NVIDIA RTX graphic cards, we can run more than one camera per single computer. And with the improvement of this algorithm, we will be able to run multiple cameras with just a laptop. And another important factor that I mentioned before, but I can't stress this enough, is like the importance of the positioning of the camera and the tracking. Because when the camera is not properly positioned and takes people from not a good angle, so the more is on the top, the easier it is to track people, because the more it's close to the ground, the angle makes people mix together, and it's very hard to to track them. So that's very important. And also when, of course, it happens that not always you can choose where to place the camera because the cameras are already there. So it's good to make a study of the specific scenario and choose like what region of interest to focus on. So I hope that this information was clear from the point of view of like development if you want to build such solution. I have a few other videos on YouTube where I explain like the difference between object detection and tracking, where we got also more in depth about the code, where other videos where I show object detection and tracking in different scenarios for manufacturing companies to identify defects on objects, to get the speed of the vehicles, and so on. So I have many other samples that you can watch on YouTube on the channel if you're interested to watch them. If you want to learn how to build easily and quickly object counting and tracking software, and you want custom code ready to run for this, I have a course called Object Detection with OpenCV and Deep Learning. You will find the link below where there is a structure, easy structure to follow to build such solutions, and there are codes with projects provided like to build similar solutions to this to detect objects, to track objects, and to count objects. Let's talk about the point of view of a company. When is it good to integrate such solution and when it's not good to integrate such counting and tracking solution with AI? We're in a phase where still there is a high cost to develop such software because they are custom software. They need to be there needs to be developer to make such solutions. So there is a high cost to build such solution. The advantage is that such solution is scalable. So once you build a solution to track from CCTV cameras for your specific needs, and if there is a lot of flow and traffic, that can be easily scalable. So to put this in perspective, if you have a small shop or if you have like a small activity and now the counting is done manually, probably it's not worth the investment at the moment to implement such solution. If you have a big flow and like thousands and thousands of hours of video to process like each month, then such solution will have a huge return of investment over time. Hope this video was useful. I will be back with other similar videos regarding object detection, tracking, counting for different fields like manufacturing, like factories, and so on. This is all for this video. See you in the next one.